Hello everyone. The topic that we are going to study today is covalent bond. This is from the chapter chemical bonding, chapter 4th of class 11 CBSE, right? Okay, let us study what is covalent bonding. I think you all must have studied about this in class 9th. Let us just revise, okay? So covalent bonding is like it is formed between the sharing of electron pairs between the atoms, right? Let us understand. Let us understand with the help of an example. Here we have chlorine, right? So you all know the electronic configuration of chlorine is like neon 3s2 3p5. Okay. So what does it mean? That the first shell has 2 electrons, second shell has 8, and the last shell has 7 electrons. That is 2, 8, 7, right? And here also it is 2, 8, 7. Now, are both of them stable? No, because the last shell does not have fully filled electrons, right? The last shell has only 7 electrons. Yes, it needs one more to become stable. So what do these elements do? They share one electron. If they share one electron, right? Can you see? They have shared one electron here, right? So sharing of these electron makes the molecule stable, right? Now both of them have a completely filled outer shell, which we call octet. So their octet is completely filled, right? Now it is stable. Okay. Now let us move on to the next slide. Yes, so if two atoms, they share one pair of electrons between them, the covalent bond between them, we call it as a single covalent bond, right? The covalent bond is known as a single covalent bond. Okay, let us see. So here each bond is formed as a result of sharing of electron pair. So it's not like there is a complete transfer of electrons, but there is sharing of electron pair. Okay, and each atom, any atom which is there, it is contributing at least one electron. For example, here we have drawn CH4, that is methane. So carbon, as you all know, it has 4 valence electrons, but it is not stable. It needs 4 more to become stable. Hydrogen, you all know that it has just one electron in its outer shell and it needs one more electron to complete its duplet. So what do carbon and hydrogen do? They make covalent bonds, right? They share these two electrons. Now these two electrons, the shared pair of electrons belong to both of them. That is the meaning of sharing, right? So now this carbon, it has 1, 2, 3, 4, 5, 6, 7, 8 and is stable. Hydrogen also has 2 electrons here and now is stable because its duplet is complete. If I would talk about water molecule, so every atom, the rule is every atom should at least contribute one electron. So let us see oxygen, as you all know. First thing is we draw the valence shell electrons, okay? Oxygen has 6, hydrogen has just 1. Can you see here? These two electrons are being shared, right? So now these two electrons belong both to hydrogen and oxygen. So oxygen now has 6 of its own and 2 it is sharing with the hydrogen. So it has 8 electrons. Hydrogen, both of them have completed their duplet. You can draw it this way also. If you would see here, oxygen 2 electrons in the first shell, 6 in the last shell. And out of the 6, it is sharing 2 with the hydrogens, like 1 with this hydrogen and 1 with the other hydrogen. This type of diagrams, we call them as dot and cross diagrams. One of the any element you can represent it by either a dot or a cross. Why? Because so that you can know, okay, cross electron is coming from hydrogen, right? Okay, the combining atoms, all of them must attain outer shell noble gas configuration. What is a noble gas configuration? That means the outer shell should be completely filled, right? That should be the result of the covalent bonding, right? Okay. So let us say this is carbon dioxide, right? If the atoms are sharing 2 pairs of electrons, that is called a double bond. Like carbon is there, okay? So carbon, as you all know, it has 4 valence electrons. Oxygen has how many? It has 6, okay? So I'm drawing first the valence electrons. Now oxygen need 2 more and carbon needs 4 more. So can we like share these 4 electrons, right? We can share them, right? So now carbon has 4 here and 4 here, 8. The octet is complete. That means carbon has a noble gas configuration. Let us count for this oxygen. 1, 2, 3, 4, 5, 6, 7, 8, right? Hence, this oxygen is also stable. What about this oxygen? Let us count 1, 2, 3, 4, 5, 6, 7, 8. Right? So the shared pair of electrons belong to both of them. Hence, CO2 is a covalently bonded structure, carbon dioxide gas, right? Okay. Now this is C2H4, which you can try it yourself. If two electron pairs are shared, we call it a double bond. Okay. Now let us study when is a triple bond formed. A triple covalent bond is formed if you're sharing three electron pairs. Let us study the example. I have carbon. So carbon has 4 electrons in the outermost shell, right? If carbon shares 3 electron pairs, right? So triple bond is formed when combining atoms share 3 electron pairs. Can you see? 1, 2, 3, right? So that means 6, and here also it is making one bond, right? So now every carbon, so this carbon, like these shared pair of electrons belong to both of these carbons. So this carbon is making covalent bond with this carbon and the hydrogen. With the hydrogen, it has 2 electrons by sharing, and with the other carbon, it has 6 electrons. So total 8. Here also total 8. So now all of them are stable and have achieved the noble gas configuration. So that is the reason these elements react, or they, form bonds or ionic bonds even. Why? Because all of these atoms, they want to achieve stability. That is the reason. Okay, so this is again example of a triple bond, that is N2 nitrogen gas that exists in our nature. So you can try this at home, right? Okay. So now this is a question which you can, answer. How do atoms form covalent bond, right? Okay. So covalent bond is formed by the sharing of electrons. So this is an example of H2O molecule, which I have already explained it to you all, right? Hydrogen has just 1 electron in the outermost shell. Oxygen has 6 electrons, right? So they're sharing these electrons, like one electron, to make a covalent bond, right? Can you see here in the image? I think it's very clear. Okay. Now we are moving on to the next topic, that is the valence shell electron pair repulsion theory, which is very important part of this chapter. Okay. So let us see. So this theory, it was given by Powell and Sidgwick, right? It was given by Powell and Sidgwick. Okay. So it was proposed in 1940. So this is based on the repulsive interaction between the electron pairs in the valence shell of the atom. So in the valence shell, what is the valence shell? As you all know, valence means outermost shell, right? So here, basically in the outermost shell, there can be electron pairs, right? And the electrons, since they are negatively charged, so the electron pairs, they face repulsion. Okay. So let us understand. Okay, so here we have these two scientists like Sir Ronald and Ronald Sidney and Ronald Gillespie. So what did they do? They further they developed the valence shell electron pair repulsion theory. These two scientists, right? Okay, let us understand the valence shell electron pair repulsion theory. Okay, now in this theory there are two different things. One is shape and one is geometry. Let us understand geometry. Okay. Now, in any atom, there are lone pair of electrons and some electrons also form a bond pair. Like just now we have studied through covalent bonding. I am drawing it for H2O here. Please pay attention. Okay, so oxygen has 6 lone pair of electrons in the outermost shell. It is sharing 2 here. So I think you can see the 2 electrons which are being shared. And it has 2 lone pair of electrons. Okay, it has 2 lone pair of electrons. So the geometry is determined by the lone pair of electrons which are there, also the bond pairs here, right? The geometry is determined by both. Okay. So according to the hybridization, I think you all must have studied hybridization before coming here. So hybridization is sp3, right? So considering its bond pairs, so there are bond pairs are 2 and lone pairs are 2. So since the hybridization is sp3, the geometry is what? The geometry is tetrahedral. So geometry and shape are both different things, right? So the geometry is tetrahedral. If I would talk about shape, please remember the shape only considers the bond pair of electrons. So you hide the lone pair of electrons. Let me make the shape for you, right? So we hide the lone pair of electrons. So you can see I am only showing the bond pair here. So here the shape is bent, right? Now we will understand through this theory that, why is this shape bent? Like I think in the lower classes, you must have been drawing H2O like this, right? But why is the shape bent? That is what we are going to study today. So let us revise. Geometry is determined both by the bond pairs and by the lone pairs, right? Shape is only determined by the bond pairs. Let us understand. Okay, before starting, we need to, know certain postulates or, the main points of the valence shell electron pair repulsion theory. The first point is electron pair, they repel each other, right? And tend to stay away. Okay. So for example, I have two, bond pairs or electron pairs, right? So obviously they have electrons and electrons have a negative charge. So any bond pair or even the lone pair, for example, the H2O molecule, right? It was like this. So basically we have two lone pair of electrons. So these lone pair, they've tried to move as far as away from each other because both of them are negatively charged and they repel each other. Even the bond pairs, they repel each other and the lone pairs as well. So you can see bond pairs are also repelling each other and the lone pair of electrons are also repelling each other. Now, different electron pairs, they have different repulsion. See, the maximum repulsion is between lone pair and lone pair because they are not bonded, right? So the maximum repulsion is between a lone pair and lone pair. For example, here, these two lone pairs would have like a maximum repulsion. Then the repulsion between a lone pair and a bond pair would also face repulsion. That means this lone pair and this bond pair would also face a repulsion. Then the least repulsion is between a bond pair and a bond pair, right? Okay. Now the geometry and the shape is determined by bond pairs and lone pairs, right? Okay. If the lone pair is 0, right? So geometry and shape both are equal. So I told you, right? Geometry considers both the bond pairs and the lone pairs, but the shape consider only the bond pair. So if the lone pair is 0, then obviously all we have is bond pairs. That time geometry and shape are equal. Okay. If lone pair is not 0, then geometry and shape are not equal. So why did this H2O become bent? The reason is the lone pair repulsions. These two lone pairs, they're repelling each other and moving farther apart. That is the reason that, the structure became like this, like a bent structure. Okay, let us understand. So as I told you all, the repulsive interaction of the electron pair, it increases like this, right? So lone pair is the highest repulsion. Then we have lone pair bond pairs and bond pair. If you would see here, the lone pair also face, they repel most, right? So if you can see here, bond pair repulsion is also there between these two bond pairs. There is a repulsion between lone pair and the bond pair, and there is a lone pair repulsion, right? Okay, let us study. Okay, so here in this case, what I am showing you is here the geometry and shape both are equal, right? Here the geometry is equal to shape because there are no lone pairs, right? So there are no lone pairs, there are only bond pairs, right? So here we have only bond pairs, no lone pairs. So geometry and shape are equal. So let me consider BeCl2, right? So beryllium has this 2 electrons in its outermost shell, valence shell. It makes 2 bonds like this. So there are 2 bond pairs only. There are no lone pairs. So geometry is linear. The shape is also linear. What does linear means? Being on a straight line. And the angle is 180. It is very important for us to know this angle. Let us consider BF3. So boron has 3 electrons in the outermost shell, as you all know, right? What is the atomic number of boron? 5. 2 electrons in the first shell and 3 electrons in the last shell. So it becomes BF3, right? Now here the structure is called trigonal planar, isn't it? It's like a triangular in shape and planar. So we call this trigonal planar. Now all the 3 bond pairs are equidistant from each other, to prevent that repulsion, to minimize the repulsion. So the angle here is 120, very important for us to remember. Okay, next shape is called tetrahedral. Again, here the geometry and shape both are equal because there are no lone pairs, there are only bond pairs present, right? So if I would take example of CH4, this shape is called tetrahedral. Here, the hybridization is sp3. So where 3 bonds are below and there is 1 bond at the top, that is called a tetrahedral structure. Very important for us to remember the, the angle, that is 109.5. Okay, let us move forward. Okay, now when there are 5 bond pairs, okay, 5 bond pairs, what is the shape or the geometry? So when there are 5 bond pairs like PCl5, phosphorus is there in between. I have 3 Cl bonds. These are called the equatorial bonds, okay? They are equidistant to each other. And then we have axial bonds, which are in the top and bottom, right? If I would join them, okay, just see. If I would join them, isn't it looking like two pyramids, right? It looks like 2 pyramids. Can you see here? It is better given in this image, right? So if there are 5 bond pairs, only bond pairs, the geometry and the shape both are trigonal bipyramidal. Trigonal bipyramidal. Okay. Yes. So the angle here is like between the equatorial bonds, that is these type of bonds, the angle is 120, and between the axial bonds, the angle is 190. Sorry, 90, not 190, 90 degrees. Okay. Here one question is asked, that is why are axial bonds, why are they longer? Because, they face a lot of repulsion from the equatorial bonds. Because of the repulsion from the equatorial bonds, the axial bonds, they elongate. So if you can see, the length of the axial bonds. Axial bonds are the ones on the top and bottom, the two bonds. They are longer, right? Okay. The next is SF6, right? That means there are 6 bond pairs, only 6 bond pairs, no lone pairs. Here, the shape is called octahedral, right? Why is it octahedral? Let us understand. If I have sulfur and I have 4 fluorine atoms here, and the other 2, I place it on the top and bottom. Okay. So if I would just join them, right? And just attach them like this, isn't it? It looks like a octahedral shape. What is the meaning of octahedral? Octahedral means it has 8 faces. Can you see? It has 8 faces. And it is also known in some textbooks, it is also known as square bipyramidal. Isn't it? It looks like there are 2 square pyramids. Like this is the above shape is trigonal bipyramidal because the base is a triangle. In this case of SF6, the base is a square. So it is square bipyramidal, square, and there's a pyramid. Okay, so square bipyramidal. There are 2 pyramids, right? And there are 8 faces. Okay. Now what we are going to study is valence shell electron repulsion, valence shell electron pair repulsion theory. That is VSEPR, what we are studying now, with central atoms that have one or more than one lone pair of electrons. Now here lone pair have started coming in. So now the geometry and the shape will not be equal. Okay. Let us see. Okay, the first example, you can see here the bond pairs are 2 and the lone pair is 1, right? So in such cases, when the bond pair is 1 and the lone pair is 2, like you can see here, such cases, it should be like the geometry is trigonal planar because the total number of bonds is how much? 3, right? But I told you for shape, you will only see the bond pair. So you hide the lone pair. So if you hide the lone pair, you can see that the shape is what? Bent, okay? Now, here, there are how many total pairs? There are 3 bond pairs and 1 lone pair. So 4. For number 4, we had studied that the geometry should be tetrahedral. But for the shape, we hide the lone pair. So now the shape becomes trigonal pyramidal, right? It is known as trigonal pyramidal like NH3, right? Actually, it should be tetrahedral, but the lone pair, we do not show it during the shape. So the geometry is tetrahedral, right? But the shape is trigonal pyramidal, right? Isn't it? It looks like a trigonal pyramid, like a pyramid, right? Okay. Next is again, there are 2 bond pairs and 2 lone pairs, like H2O molecule, as I told you. So as we have already discussed, like the geometry of this is tetrahedral, but then we hide the, for shape, you hide the lone pairs. You don't see the lone pairs. So you see the shape. So the shape is what? It is bent, right? Okay. Let us see for 5. Number 5, we have 4 bond pairs and I have 1 lone pair. Okay. So the shape like SF4. So I'm drawing it like this, SF4. Okay. So if you can see, there is like I have 1 lone pair and 4 bond pairs, right? So here actually it should be trigonal bipyramidal. If there are 5 bonds, you remember PCl5. The geometry is trigonal bipyramidal, but for shape you hide the, you hide the lone pair. So isn't it? It looks like a seesaw. So let me draw it for you. So if you can see, it looks like a seesaw. Yeah, it looks like a seesaw in the park. So you can imagine you are sitting here and your friend is sitting here. So it's like a seesaw. Okay. Next is trigonal bipyramidal, right? Again, but here same, like the number of bonds are 5, but here the lone pairs are 2, right? Like ClF3. Okay, so we have chlorine and I have ClF3, right? Okay, and I have 2 lone pair of electrons here. 2 lone pair of, because chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. It is making just 3 bond pairs. Okay. Actually, if there are 5 pairs, bond pairs plus lone pairs, together if they are 5, the geometry should be trigonal bipyramidal. But as I told you, for shape, we see only the bond pairs, right? So you can see only the bond pairs. The shape is called a T shape. Isn't it looking like a T? right? It's looking like a T. Okay. Let us move next. Okay. Next, the number 6. If there are 6 bond pairs, total 6 pairs, like adding of bond pairs and lone pairs, the geometry should be octahedral. So here they have written octahedral, octahedral, right? But if there is one lone pair, now the example is BRF5. So I'm just going to draw it here, bromine, and I have 5 fluorine atoms, right? And one lone pair here at the bottom, because bromine has 7 electrons in the outermost shell, so it is making bond with 5, the other 2 are here. So if I would just join it, isn't it, it looks like a square pyramid, a pyramid which has a square base, right? So we call it square pyramidal, right? What do we call it? Square pyramidal. Okay, we call it square pyramidal. Next up, we have 2 lone pairs. The total pairs are 6, so obviously geometry is octahedral, right? But I have 2 lone pairs of electrons here. So now what happens? Now my geometry, my geometry is octahedral, but my shape becomes square planar. The example is XeF4, right? So Xe is xenon. Okay, HCF4, if you can see. Xenon has 8 electrons in the outer. See, this is the violation of the octet rule, if you would have studied. Xenon is a noble gas and it does not have any need to, make bonds, but still it is making bonds, right? So there are 2 lone pair of electrons at the top and bottom, right? And then there are 4 bond pairs. So it is making a shape which we call as square planar, right? A plane square, square planar. So for us, it is very important to understand and to remember the shape, to remember the geometry, right? And also to remember the examples. In exam, what they will ask? They will ask you, okay, please tell us, what is the shape of XeF4? What is the shape of a water molecule and why? So you need to explain. It is due to the electron, due to the repulsion of the lone pair, the shape becomes bent, right? Okay. Let us do some questions, right? Um, Okay, they are saying that, you have to explain the geometry of SiH4. So silicon is there. Silicon is in the family of carbon. It has 4 electrons in the outermost shell. So there are just 4 bond pairs, right? And we know for 4 bond pairs, what is the geometry? Tetrahedral. Here, there are no lone pairs. So the shape and the geometry becomes equal, right? So shape and geometry both are tetrahedral and the angle is 109.5, right? Okay, now this is this, yes. For example, SO2, see here there is one lone pair, right? One lone pair is coming. So here, can you see the structure has now become bent? So number of bond pairs is how much? Number of bond pairs you can see is 4 and number of lone pairs is 1, right? The structure here is a bent structure due to the lone pair repulsion. Okay. Next, let us quickly see ammonia. As I already told you, it's a trigonal pyramidal, right? It should be, actually, its geometry is tetrahedral because 3 bond pairs and 1 lone pair. Geometry is tetrahedral, but the shape is trigonal pyramidal. Okay, 3 bond pairs, 1 lone pair, right? Can you see the shape is a trigonal pyramidal shape because of the repulsions, to minimize the repulsions between the lone pair and the bond pair, right? Can you see? It is trigonal pyramidal due to the lone pair bond pair repulsion, right? Okay. Next is H2O. We already know that, the number of bonding pairs are 2, the lone pairs are 2. The shape is again bent, right? Because of the repulsions. Next. Next, I have SF4 molecule. Okay, so the number of bond pairs are 4, the lone pair is 1, right? Okay. So this is which, can you tell me the shape? The shape is seesaw, right? It is seesaw. Okay. So the lone pair is present at the equatorial position to minimize the repulsion. Okay. It is seesaw. As I already told you, you can see on the slide, it's seesaw. Okay. ClF3. If you would see ClF3, we have already seen it. There are 3 fluorine bonds and 2 lone pair of electrons, right? And to minimize the repulsion, the shape is like this, right? The best shape, the first shape is the best shape because the lone pairs are present at the equatorial position. That is a shape A. Okay, the lone pairs are at equatorial position, so less repulsion. And we have studied this shape. We call it the T shape. Okay. Quickly, one question. According to valence shell electron pair repulsion theory, what will the shape of XeF4? Okay, so you have to first make xenon. You have to make the valence shell electrons. You need to make 4 bonds and count how many bond pairs are there, how many lone pairs are there. So here there are 4 bond pairs and 2 lone pairs. Okay, actually it should be octahedral, but it is not octahedral. It is what? It is square planar, right? This is how it looks. The geometry is octahedral, but the shape is square planar. Okay. So thank you so much. I hope you really understood what is valence shell electron pair repulsion theory, what is covalent bonding. Okay, so this topic is a really important topic for class 11th chemistry, as it will also help you in class 12th chemistry. So if you want to study this in detail, you can get in touch with me through Urban Pro. Yes, okay. Thank you so much.